My name is Sebastian Katsaros, and this is a presentation about the paper by Prem Kumar Singh about bipolar fuzzy attribute implications. Let's get right into it. In the introduction, we have what are bipolar fuzzy attributes. These are used to define something based on a bipolar system of values, essentially being able to assign something a value in a range of from a positive value of 0, comma 1 all the way to a negative value of minus 1, comma 0. Essentially, this value describing a trait, an attribute of said object. This was inspired originally by the yin-yang theory, where, as you can see here, we have multiple traits which have two extreme sides of them which we could use in a system like this exact, like order versus chaos, masculinity versus femininity, and so on. What is the problem that the author finds that he wants to try and solve using this theory? He finds that there is a problem in the management of large numbers of these bipolar fuzzy concepts. And so he finds that there is a need for efficient multi-decision processes using chosen attributes. And so the solution he proposes is the introduction of a method for deriving bipolar fuzzy attribute implications and their measurement using accuracy functions, as we will see later. But first, we need to know some key definitions which are going to come up, which we need to know. First and foremost, being the bipolar fuzzy formal context, which is a triplet of three arrays, one being a set of object X, Y being a set of bipolar fuzzy attributes, and R being the bipolar fuzzy relationship between the objects in X and the attributes in Y. Next, we need to know about the residuated lattice, which is a simple mathematical structure which represents truth values, like this. Next, we need to know about the bipolar fuzzy attribute implication, the important one, which is basically an attribute implication, is an expression like this, where A and B are fuzzy sets of attributes. This expression implies that an object, if it has attributes A, then it also has attributes B. We will go on to see more of this in the example that the author proposes later on in the paper. Next, we also need to know, though, about the bipolar fuzzy set representation of an object. Each object X in the array we saw before in a given bipolar fuzzy formal context K, like here, right here, we can be represented by a bipolar fuzzy set A like this exactly. Now, this is a little complicated. It's a little weird, but the y's, y1 to ym, are our bipolar fuzzy attributes, just like the y right here we can see in the fuzzy formal context. And these expressions with the mu's being the bipolar fuzzy memberships defined among, in this case, xy and ym in the given bipolar fuzzy context again. Next, we will see the proposed methodology of the author for solving the problems he has defined. So the methodology is as follows. First, we input our data as a triplet like we saw on the one before. X being objects, Y being attributes, R being the relationships between them. Next, we can compute two metrics, support and confidence, for these bipolar fuzzy attributes. These can be computed as we see below here. This being the support, where in this case yj is a subset of our attributes, and absolute x being the total number of transactions we have, and the confidence metric being able to be computed right down here. This is the equation that gives us the confidence of this expression between the two different set y subsets of attributes. This the author does not dive much deeper into. He simply uses this later in the proposed example he has. Next, though, we will see the third step the author tells us is we can measure the accuracy in this case as well, another metric we can measure, which is given by this equation right here. In this way, the support and confidence of bipolar fuzzy attributes can be represented as a single value for more precise analysis. Lastly, after these measurements, we can also refine the implications we get from these measurements based on user-defined thresholds depending on the needs of the current problem. To see one problem like that, we can go to the illustration example which is provided by the author in his paper. In this case, we have 4 objects which represent different cars at a dealership which customers may select and buy, and 3 attributes of these cars, which in this case represent reasons why people decided to buy or not to buy specific cars. Y1 being their beauty, Y2 being the cost, and Y5 being the luxury feel of the car. To better understand the numbers given in this table, let's take an example of the first one, the first attribute of the first car. We have 0.4, negative 0.5. Basically, this means that 40% of people who selected that car was because of its beauty, while 50% who rejected the car did it for the exact same reason, for attribute Y1, the beauty. If we take all of these numbers now, we can derive the implications we wanted so as to get our results and be able to analyze the given data better. Let's take the implication y1 to y2. From the previous equations, the author computes that we get a support, in this case, of 0.31 and a confidence of 0.72, which means essentially that the attributes y1 and y2 appear together in more than 31% of cases where the card specifically was sold or selected, while in 72% of cases where a customer considered Y1, they also took into account Y2. Continuing with this very same logic, the author goes on to compute the other implications and presents his results as we see right here, with the support and confidence metrics of these very implications. He also goes on to give us an analysis, a personal analysis of these results as we see here. Unfortunately, though, he does not delve into deeper details about his thought process behind these. Now, he then continues on to also mention that the results from this experiment align well with the ones from the concept lattice structures and granulation methods, which he has analyzed in some of his previous work, which he has linked in the original paper. I am not going to delve further into these as these are outside of the scope of this presentation, but you are free to go and check them out yourself. Next, the author gives us some of the applications he believes his methodology could be used in. One being knowledge processing, in which he believes his methodology could help with the enhancing of decision making tasks. And two being in quantum data intelligence, where he believes it has the potential to improve handling of equilibrium in quantum information. Lastly, the author goes on to give us his conclusions about his work, where his key contribution he believes being his novel method for generating and analyzing bipolar fuzzy attribute implications, and the significance of this being that it is effective for large data sets and multi decision processes. At the very end, he also mentions that in the future, the author with his work would like to expand to M-polar fuzzy spaces and to use more advanced metrics for broader applications of this work. Now, at this point, the paper ends, and also my job here, I believe, is done. And so I would like you to thank you for watching this video, this presentation, and I wish you a nice rest of your day. Thank you.